Good. So between 4 and 10. 4, 6. So this is 6. The distance is 6. So
change it to 6.
Say it again.
I'll change it to 6.
You want to change this to 6?
Yes.
Okay, so in that case, 4 to 10. In the middle we have 7, 5, 6, 7, 8, 9. Now you want to use the midpoint, you want to use the leftmost point, the rightmost point.
Let's do rightmost point.
Good, so which means that we'll have to go with this. 6 subintervals. So the integral from 4 to 10 x squared cosine the square root of x dx is approximately base times height. The base is 1. I'm not going to even write it. So it's f of 5 plus f of 6 plus dot 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 plus f of 10. I'm not going to do this by hand. So let's go to stat and edit 2 lists. So let's edit the first list, in which I put 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. And now I go to the top of list L2, and I have to put in the function, which is list L1 squared times cosine of the square root of list L1, go outside and close the parenthesis. So what does this do? We'll take each x entry, square it, and multiply by cosine of the square root of that number, and give us all the answers at once. And then we get out of there and go to stats and do one variable stats on list L2. You only need the second item, which is the sum. Negative 233.982278, which is very possible. Questions? Questions?
Could you show that part on your calculator again?
Yes. So first, did you enter list L1? 4, 5, 6, 7, 8, 9, 10. But I forgot to put 10. Okay, I forgot to put 10. So 4, 5, 6, 7, 8, 4, 5, sorry, 5, 6, 7, 8, 9, and 10. Don't forget 10. I forgot 10. So the answer is not correct because I forgot f of 10. Okay, so go and highlight list L2, just the top of the list. And you want list L1 to be squared, list L1 squared, because that's what the function is all about. We have the list L1 squared times cosine of the square root of list L1. Go outside and close the parenthesis. And this is your function. So the calculator will multiply the first entry, 4 squared cosine of the square root of 4, and then the next one. And it will give us all the answers at once. And then you second and quit and go to stats and perform calculations, one variable stats with list L2. So it's negative 333.96. negative 333.96. And that is a pretty good approximation, I'm sure. Very good. Next question. Is that what you had in mind, the approximation?
Yeah. That one wasn't quite like the one on the web assigned, but I wasn't really sure.
Let's do the one you have on the web assigned, that's fine.
Alright.
I'm ready.
This is the f of x equals x squared plus the square root of 1 plus x, or 2x, sorry. And then the
Here,
interval is
1
2
plus
to 4.
2x?
Yeah.
Okay, and the interval?
2 to 4.
Okay, and how many subintervals?
So we're solving the limit as n approaches infinity. And we're using right endpoints.
But how many subintervals?
It doesn't specify. It says use the definition with the right endpoints to find an expression for the area under the graph of f as a limit. Do not evaluate the limit.
Oh, so we are not asked to find the limit. So you're only asked to find the preps. You're asked to find the preps and write the limit. So the prep will be delta x is 4 minus 2, so it's 2 over n. Xi will be 2 plus 2i over n. And the function will be 2 plus 2i over n squared plus the square root. We did this last time. Plus 4 plus 4i over n. Or 5 plus 4i over n. And then you're only asked to write this limit, where delta x is 2 over n, and this is this function. You're not asked to approximate, you're only asked to present the limit. They're just checking that you understand how to create the 3 preps and put it together into the limit.
Okay, that's a much simpler question than I thought it would.
Okay. Is this okay now?
Oh yeah, that's a lot better.
Yeah, we had we had an example last time. Somebody asked, you or somebody else asked the same question. So here it is. It was a different function. Somebody gave me a different function. Oh no, it was exactly this one. On page 5 last time.
Yep, that's my bad.
No, that's okay. Anything else? So what I would like to do next Wednesday is